Hi, everybody. We're going to keep talking about similar triangles, just like we were talking about before when we went on break. Remember that we learned that we could tell that two triangles were similar if they had three sides that were proportional. So side, side, side was one of the cases we were looking for. Also, we could tell that triangles were proportional if you had a side and an angle in between and another side. So side angle side worked. Also, if you had two angles on both of the triangles that were similar, that were the same, then those triangles would be similar. So the directions to this page says state if the triangles in each pair are similar. If so, state how you know they're similar and complete the similarity statement. So first of all, we're going to look at these problems and see if side, side, side works, or maybe side, angle, side, or maybe angle, angle would work. If you look at number 1, you see that two straight lines cross. And we learned that when two straight lines cross, those angles that they form, those vertical angles, are always going to be the same. So we've got two side lengths given and an angle in the middle. So maybe that is the case of side, angle, side. So we'll write it up here, but we'll make a question mark right here because we don't know for sure till we look at the proportions that they really are side, angle, side. Let's look at this smaller side right here. 39. And if we go over to the other triangle on the same line, we have 16. So 39 over 16. And we're going to wonder if it is the same proportion as those other two sides. We've got 40. And if we follow that line up, we also have 16. Now, if we just think about it for a minute, 39 divided by 16 is not going to be the same thing as 40 divided by 16. So let's make a line right through that equal sign. We'll say it is not equal. We'll actually maybe cross out that side angle side thought because those sides didn't work. And so you're going to write here not similar, because if you don't have all the cases working, then you don't have similarity. Okay, now let's go look at number 2. Number 2 has all side lengths given. So the one that we're going to be looking at proving is side, side, side. We'll put side, side, side up here as a thought and maybe put a question mark by it because we haven't proved it yet. And remember, one of the ways that we learned in class to keep everything straight and compare the things that go together is to write the small, medium, and large by each of the side lengths. 48 is the smallest side. 72 is the medium, and the longest is 84. With the other triangle on the right, the 8 is the smallest, the 12 is the medium, and the largest is the 14. So I'm going to be taking the small sides first. 48 is the smallest on this triangle on the left, and on the right, 8 is the smallest. So 48 divided by 8. If we do that, 48 divided by 8 is 6. Now let's do the medium sides. We've got 72 divided by, and the medium side over there on the right triangle is 12. So 72 divided by 12, that's also 6. Now we'll take the largest sides. 84 divided by 14, that's going to be 6 as well. So 6 equals 6 equals 6. We have proved that we have side, side, side. You can circle that. And now the trick is to write the similarity statement in the right order. Angle C is the first one that they start with, and it moves to angle B, and then to angle A, CBA. We have to do that same order corresponding with the triangle that's on the right, on the left. So we're going to go, the C angle is between the large and the small. Large and the small angle between the large and the small side is angle F. So we're going to start it out with the symbol for the triangle, triangle F. And C to B went through the small side. So go through the small side again to G. And then the last angle is just H. So this triangle is called FGH. and order matters. You have to have it in that order. Problem number 3, the first thing that we want to do is mark those vertical angles as being the same. So draw the arc, and you see that you have a side length and an angle and a side length. So maybe this is side, angle, side. But you might want to put a little question mark because you haven't proved it yet. So let's go and say that this is our small, this is our medium side, this is our small, the 28, and the medium over here. So we're going to go 8 over 28. And then when we do the division, we have 0.2857. And I've worked out these numbers ahead of time, but you can see that I have the Desmo Scientific Calculator open here. You guys can use that. It's a good calculator for this purpose. Now, medium over medium would be 14 over 49. And if we do that division, that is also 0.2857. They're exactly the same. So we do prove that this is side, angle, side because we have that angle and those two sides are proportional. It does work. So now we just have to worry about putting it in the right order. The first triangle goes V, U, T. Of course, V is the same in both triangles. So we're going to start with triangle V, but then we have to decide what's first. Do we go first to L or do we go first to M? And the way we decide that is V goes to U. V going to angle U goes through the small side. If you go through the other small side, that goes to L, not M. So it goes V, L, and then the last side is M. Okay, that one's done. Let's look at number 4. Number 4, if you check out these angles, you have one angle with one arc. In the other triangle, you also have one angle with one arc. In the top triangle, you also have a triangle marked with 2 arcs, and in the bottom triangle, you have an angle marked with 2 arcs. So without doing any math, this is kind of the easiest one they might give you. You've got 2 angles the same, so you do have 2 similar triangles because of angle, angle. Now all you have to do is worry about order. And order is also kind of easy because they go J, K, L. J has 1 arc, K has 2 arcs, and L has nothing. So if you go in that order 1, 2, and nothing, you'll be just great. So write the triangle symbol, and then the angle that has 1 is T. The angle that has 2 is U, and the angle that has nothing is V. So that's T, U, V. Okay, now let's look at number 5. Number 5 has some things that we can mark as the same. Again, we have 2 lines that are straight and crossing, so we have those 2 angles that are vertical. They will be the same. I probably shouldn't mark them as 1 arc though because they've already used the 1 arc here. They've also already used 2 arcs and they've also used 3 arcs. So, oh my goodness, if I wanted to be really, really right, I would have to write 4 arcs right here. So, I'm not going to write 4 arcs. I'm just going to differentiate it by making a dot. So in this triangle, remember, in order to be angle, angle, which is all we can do because that's all we've got to prove, we have a 2 and a 3 and a dot. This is a dot and a 1 and a nothing. So you can see that even though these triangles look similar, you have to write not similar because those angles are not the same. Okay, that was a nice one, kind of easy. Let's go look at number 6. Number 6 says triangle KLM, that's the whole triangle, is similar to another triangle. Well, the other triangle that they're talking about is this triangle that's smaller in the bottom left-hand corner. and it consists of K, B, and C. But we have to prove that they are similar. Maybe they are and maybe they aren't. We do know that K is the same in both triangles. So we might have a side angle side situation here because we've got side lengths and an angle that's the same and then some more side lengths. But remember, you better put a question mark up here because you haven't proved that those sides are proportional yet. We know from K to L is 88. We know from K to M is, we might have to do some math, right? Because part of it is 25 and another part of it is 107. If we want to know the whole way from K to M, we need to add 25 plus 107, and that's going to be 132. So now we have the whole way from K to L, and we also have the whole way from K to M. So with a little triangle, 16 is the smaller side, and we'll call 25 the medium. This is the smaller side over here, and we'll call this the medium. So let's compare small to small. Let's go 88, or let's go 16 actually. Let's put 16 on the top and 88. It doesn't matter whichever way you wanted to do that, but for my numbers to work out that I worked out before, we'll do it the same way as I did it. So 25 now is the medium side, and it's going to go over 132. If we do this division, 16 divided by 88 is 0.1818, and it just repeats forever. If we divide 29 by 132, we have almost the same. We have 1, 8, and then not a 1, we have a 9. And do you see how that even though they're very close, they're really not the same. They're just a little bit off. So you need to write they're not similar right here. And then you need to cross out side angle side because it really isn't side angle side. Okay. Now your assignment is going to be a lot of similar stuff. The second page, going from 7, 8, 9, let's go all the way to 12. Those are your assignments. But we're going to keep going and we're going to talk about some slightly different stuff. In this case, now they've told us that the triangles are similar, but they've left off some information and they want us to find the missing side. You can see that those angles 35 and 35 are the same. That's important information so that we know they're similar, but we actually don't need the 35s to be able to do this problem. You could kind of cross them out if they're bothering you or just ignore them. If we say that KL is the small side and KJ is the medium side, then JL would be the long side, small, medium, and large. And then if we come over to this one, here's the small, QP would be the medium, and PR would be the large. Make sure, just like before, that you match up the same thing. So your M has the question mark. That's what you're supposed to find. Let's call that X. And we'll put it over the other medium side, and we'll get that value down there as 33. We're going to be able to set up an equation with the large side 28 over 42. And remember, when you're solving for a variable, when you have two fractions like this in a proportion, you can cross multiply. So you're going to cross multiply x times 42, that's 42x. Then you're going to multiply 33 times 28, 33 times 28 is 942. Actually, 924. Okay. Then you're going to divide away your 42, so you can leave x all alone. And 924 divided by 42 is 22. And that one's done. Okay. I'm going to circle 14. That's part of your assignment. You can do that one on your own. But let's go ahead together and talk about 15. 15 is a little bit different in that they want you to find not the side of the smaller triangle over here, but the piece that's left after the triangle, the small triangle, has been taken away. You solve that in the same way, but we'll set up things that go together. Like maybe we'll look at the whole triangle, so we'll call it the whole triangle over just the top stripe, and I'll call that just whole over top. Proportions are great as long as you keep them the same and be consistent and have a plan, then you're going to usually end up doing it right. Now I need to know what this bottom base measure is. Part of it is 18, part of it is 6. To find out the whole thing, I need to add them together. So 18 plus 6 is 24. Now, if I'm comparing the whole thing over just this top stripe, then 24 will go with 18, and 12 will go with what we want to know, that question mark. Let's change that question mark to an X. And we'll set up our proportion. 24 over 18 equals 12 over X. Okay, just like before, we're going to cross multiply. And 24 times x is 24x. I'm going to take it over here because I'm running out of space. And 18 times 12 is 216. Then I want to divide away my 24. And x equals 216 divided by 24 is 9. So x is 9. Number 16 is a lot like this number 15. You can use this little triangle. You could do the big triangle over the little triangle. I would suggest maybe that's how you set it up. Big over small. But remember, when you do the big triangle, you also have to figure out how long is this P to Q. And to do that, you'll need to add those two lengths together to get this piece. Then you'll know how long this side is on the big triangle. Okay. All right, let's move on to number 17. Number 17, these triangles are also similar. They're going to be a little bit different because, look, on one side we don't have just a single x, we have actually an expression. It still is good to start the same way that we did before by writing our smalls and our mediums. There's our large side over there with nothing on it, so we'll ignore it. If we come on over here to this triangle, the small is the 70 and the medium is the 11x minus 4. Now I have to admit that I really have just eyeballed it, but I'm trusting that they're drawing them at least sort of to scale. So that looks a little longer. That's why I called it the medium. And you can usually trust with these worksheets that they're done pretty well. So let's set up small over small. So I'm going to start by going 50. That's that bottom smaller triangle over 70. So small over small. Now when I go medium over medium, I'm going to go 60 on the top, and then I'm going to write this whole expression, 11x minus 4. And the process is just the same. You'll just have a little bit of extra steps when you solve the equation. 50 times 11x minus 4, you write that like this. 50 parentheses 11x minus 4. And then you multiply 70 times 60, and that's 4,200. Then, guys, remember what you do when you have a number outside a parenthesis. That's your distribution. You're going to multiply 50 times 11, and then you're going to multiply 50 times 4. So 50 times 11 is 550. And there's an x there, so it's 550x. And then there's a minus there, so that answer is going to be negative. 50 times 4 is 200. And then I'm going to bring down the equal sign and the 4,200 so I can continue my equation. Remember that the variable is always last. So go over to this minus 200 and do its opposite. So adding 200 to both sides. That will cancel out that 200, leaving only the 550x on this left-hand side. And then 4,200 plus 200 is 4,400. Now we need to divide away our 550. You can throw that in the calculator. 4,400 divided by 550, and that ends up giving you 8. So this x that we were supposed to solve for up here, it equals 8. Number 18 is a lot like number 17, so that will be assigned. Let's go look at number 19. Now you have two triangles here. You have the top smaller triangle that's sitting on top of the big larger triangle. So JTU, and it's compared to JLK. They tell us that those are similar. So I can set up 27 over 72 and say that it's going to equal, I use the little triangle first, the 27 is on top, so I'm going to use this, negative 4 plus 4x over 64. And then in just like the opposite, like the problem that we just worked, we're cross multiplying. 72 multiplies by negative 4 plus 4x, and I put those in parentheses so that I can distribute later. And then I multiply 72 times 64. 72 times 64, sorry, 27 times 64. 27 times 64 is 1728, so 1,728. Okay, now we need to distribute. 72 times negative 4 is negative 288. And 72 times 4 is positive 288. And there's an x there, so bring it down. And bring down your 1728. Now remember, the variable wherever it is always last, so you want to do the opposite of this negative 288, which is positive, adding 288 to both sides, the left side and the right side. So the 288s are gone on the left, but we have 288x equals, and if we add those numbers on the right together, we get 2016. The last thing we need to do is divide 288 away. And when we do that division, the 288s will cancel, and 2016 divided by 288 is 7. So that's done. Number 20 is very like number 19, except they're not exactly on top of each other. Just to start you out, I would just say that this side is shorter than that side. So let's write S over here on the left, and on the right, let's write medium. And it's kind of the same way over here. Here's the small side, and there's the medium side. So when you set up your proportions, make sure you're matching up the same things with the same things. Okay, good luck, guys. Email me if you have any problems.